Hi everyone, and welcome to the first video of the SuperDevs Fellowship. SuperDevs is a Solana bootcamp and a Rust bootcamp that I'm running. It had around 2,300 people who participated, and only 120 got in finally. I take a personal session with these 120 people every week, and this is week one. The goal of SuperDevs is that by the end of SuperDevs, someone becomes a good distributed systems engineer. They become decent at Solana, and the top 20 people who graduate from SuperDevs get a $2,500 stipend. This is the very first class of SuperDevs. We'll go through the orientation from Aditya, who leads Superteam in India, followed by a class by me on macros. If you have not done Rust Bootcamp 1 and Bootcamp 2 on YouTube by me, this will be a little hard to follow. So if you want to follow this video, go to Rust Bootcamp 1, then Rust Bootcamp 2, then follow this video. And I'm also posting the assignment that all the SuperDevs folks are doing, linked in the description. You can try that assignment as well. From here onwards, we'll post all the videos of SuperDevs on YouTube. I'll see you over the next 8 weeks. With that, let's get into the video.
Slightly exciting stuff. Slightly aggressive syllabus as well, but hopefully, enough to get you up to date with what's needed, or what's left. Probably, I'm assuming most of you. So you are selected amongst 200 people or something like that. The net number of people selected in the end are 125, around 130. Matlab, 5 more people got added. So 130 people are added. Proc macros or declarative, both of these are what we learn about today. How do you know though? How did you know we're going to learn about macros? Are my slides leaked already? But yes, we will learn about macros and both procedural macros and declarative macros. That's probably going to be the class. I'm actually very interested to see how many of you already know this. I announced it. That makes sense. All right, we will start in, my bad. Aditya is here as well. So to give initial context to everyone, Aditya leads Superteam, I think in a bunch of places. I don't know his official, I don't know how to deduce it. Sorry, I should have prepared this, but you guys already know Aditya, hopefully. He at least leads Superteam India. I think he leads a bunch of other regions as well. He'll introduce himself. He'll basically let you guys know what is expected out of this. I think a lot of people are spending a lot of time, energy, and a lot of other things to make sure this is a success. So how should we spend the next 8 weeks? What should you guys focus on? And what is the end outcome that we're hoping for is what Aditya will take us through. With that, Aditya, over to you.
All right. Hey, folks, can you hear me? Can you see me? All good. Okay. Thank you. Thanks for having me on here. I think I'll just take like 5 minutes to talk about what I think is, was the genesis of Superteam. I joined Superteam as a member back in 2021. So I'll just share a bit about, the core insight and why that matters to everyone here, why you should care about that, and how you can get the most out of all the time and effort that you're spending on what is a pretty rigorous program. Okay. If you have any questions, just drop them in the chat. I'll try and take them as we go. Who here has heard of internet capital markets? This meme that has sort of taken the Solana ecosystem by storm. I don't know that, yeah, okay, few more folks. Yeah, I see a lot of plus ones. Okay, so internet capital markets has sort of, sort of catapulted in maybe towards the end of last year, early this year, and for the meme of this year, right? Yeah, there's a lot. And the idea of internet capital markets is that you want anybody to be able to have asset ownership to sort of minimize the barriers to it. But there is the precursor to internet capital markets and sort of the foundational base layer of the Solana ecosystem is a global talent market, right? Is the idea that if you have a laptop and an internet connection, you should be able to earn in global capital assets, right? If you were here in the early days, you would have heard Akshay talk about the TCP/IP visa, which is replacing the H-1B visa in a sense that you can, from no matter where you are, you don't even need to be in like a metro city or a big city anywhere in the world, from your hometown, from the comfort of your hometown. If you have skills and if you can deploy them over a laptop, you should be able to convert that labor into capital, right? I think one of the things that everybody who does ecosystem building through all the super teams and there's so many programs now to, to learn how to build the hackathons, there's accelerators. I think a good lens to view all of these from is a medium for you to convert your labor and your skill into capital in the Solana ecosystem, right? The benefit of having a blockchain that has low fees and fast finality, high performance is that you should also freely be able to convert your labor into capital, which is to say that the things that you learn, you can deploy those skills to access global earning opportunities, which will let you escape local college placements. Right? And I think that's something that everybody here has somewhat already opted into. That's a lot of what Kira talks about is about, being able to learn and work remotely. And I think a lot of the Solana ecosystem organically leans towards that as well. So what I would say is that, yes, you will learn a lot of technical skills through the course of the fellowship. But you should also focus on how and where you choose to deploy those in the broader like Solana ecosystem. So you've got and everything is, and the goal is to create an abundance of these, right? So you have hackathons, you have bounties, you have grants, you have like accelerator programs, you have gig work. But instead of getting fixated on any one or two of these, try and think about finding a group of people that you can take on challenging problem statements with and punch above your weight in terms of the impact that you can create. And the hope is that the kind of ecosystem all of us are working hard to create is one where capital can find you really fast, right? So whether that is through grant funding, through venture funding, through gigs, through jobs, I think that's a good lens to sort of look at the ecosystem with. And so that's broadly what I wanted to share, is that as you learn over the next 8 weeks, as you sort of level up and sharpen your development skills, also think about how you want to participate in the global labor market or the global sort of talent market that is unlocked by Solana, whether it is through all the different super teams, through the hackathons, through all of the other ways available to you, because that's basically one of the ways you could get disproportionate return through which you can then participate in internet capital markets, right? Like that's broadly the sequence to it. Earn your first crypto, don't buy it. And so we're hoping to create an abundance of those opportunities. And for anyone, it's not for everyone, but for anyone who's willing and able to deploy their skills in the ecosystem, we hope to be able to find you an abundance of those. And thank you so much to everybody for spending your time and energy towards this program. Really excited to see where this goes. That's pretty much everything.
Thank you, Aditya. I think super motivating. W in the chats for Aditya over here. Thank you, Aditya. I think you only helped put all of this together. He's helped us throughout the filtering process, classes, structure, final outcomes, and it's because of him that we've been able to make this possible. So thank you for that, and hopefully now it's your all's turn and my turn to make sure we're able to achieve the final outcome from this cohort. With that, I think we will move over to discussing. First, like for the next 10 minutes, I'll just talk about what is expected of super devs, or call it the classes, the cohorts, the assignments. I'll probably share my screen for this. But basically, this is the first time I'm doing this. Fellowships have happened in the past, and I do run cohorts, but this one's a little different. This one is supposed to be fairly actionable. Like we could have filled more people, but the goal was to find a ratio very close to like 1-2%. The final one that we landed at is 5%. You guys are the top 5% of the 2,500 or 2,200 people that applied. That I think is enough metric. I'm sure there are some false positives or some false negatives, and we were able to miss a few good people, and maybe a few bad people have joined, I don't know. But overall, I think if there are 120 people that have been selected, currently on the call, we have 101 people, so 20 people are missing. Amongst those 120 people, I'm assuming 70, 80 are if you do a litmus test, they'll be able to do well. The goal is over the next 8 weeks, we're going to learn about some very nuanced and specific topics on Solana that are either generally asked in an interview or something that is not available on the internet already. I think core knowledge about Solana, client-side Solana, writing contracts, Anchor are fairly popular, and I'm sure some of you have written them. There's like one step ahead of these that we need to get to. Very high level, I've created a syllabus for the next 8 weeks. This is what it looks like. So we'll start off today with meta programming, which assumes you already know Rust and a bunch of prerequisites. So I'll take you through the prerequisites as well. We'll check how many of us understand this. We had put them on the website, and you guys have passed 10 or more test cases. So I'm assuming that you can write Rust code. That is the assumption. But honestly, let me know if that's not the case, and we can go slow as well. We can do 2 classes a week as well. The goal isn't we just, what I teach only 5% of the people understand. The goal should be at least 85 to 95% of the people who are on a class are able to understand what's being taught. And that will happen with a combination of you guys doing a bunch of hard work on your own during the week. I think we've said this before, but this is close to a full-time commitment, which basically means at the very least, assume you're putting in 25, 30 hours a week. And if you have other commitments, most probably you'll start to fall behind unless you've already done a bunch of these things, then it'll be easy. There are too many monkeys over here too. high level, this is what the next 8 weeks are going to look like. Today, we're going to spend as much time as we can on Rust. We'll do a bunch of assignments and meta programming, which is specifically what are macros and how can you use Rust to write more Rust code is what we will learn. You don't really need this unless you're writing a framework like Pinocchio or Anchor. Only those developers, if you eventually want to work at, I don't know, 𝗟𝗶𝘀 or a backpack who are leading these projects right now, Anchor and Pinocchio respectively, then you probably need to understand how macros are written. But if you know how macros are written, I think you can at least use them in the future. If you understand how things are working under the hood, you don't need to, but there's no downside of knowing them. And they may or may not be asked in an interview. Then we'll spend some time here, which I'm hoping you guys already know. You understand the accounts model on Solana. You understand what are PDAs and the various types of accounts that exist. How do you create any specific application on Solana, and how is it very different from Solidity or the Web2 world, an SQL database, so on and so forth. We'll still spend time here, but I'm assuming you guys understand these things. Primarily, token program is the biggest or the most biggest volume generator, I would say, both in DeFi or otherwise. Like token creation is the biggest use case right now, or the biggest money maker. Pump Fund is the best example of this. So we'll spend some time here. Private key management, very specific use case for very specific companies, but again, big companies with big volumes. Centralized exchanges, Privy, which I think they got acquired recently. But again, every company that's using login with Google right now is using Privy. So how do these companies do private key management? Tippling is another example. Payment infrastructure for centralized exchanges, again, a very big market. If I don't know the exact numbers, but I would assume it's like 50-50 split between centralized exchanges and decentralized exchanges right now when it comes to volumes. So we'll understand how centralized exchanges are built. Thankfully, I have a lot of experience in this. So we'll be able to dive deeper into this. And this will help you not just in a centralized exchange, in general finance or HFTs. You'll understand all the finance that are needed to trade on centralized exchanges over here. The next section is going to be the same thing on decentralized exchanges. So what is DeFi? How did it start? The popular algorithms today to swap, indexing the blockchain, and lastly, last one is slightly advanced, and we'll see if we do it or whether or not it's needed. But it's mostly if you want to do things indie, if you want to run a bunch of bots, liquidation bots, 𝗟𝗶𝘀 bots, is when you will require this knowledge. But at least today, or I guess the important bits are going to be week 1 to week 7. Week 8, we'll see optional. That's a high level of the syllabus. We'll have a class. I'll just write this down. We'll have a class every Tuesday. So Tuesday, 7 to assume 10, 9:30, 10 is when we'll have our classes. That's 7 p.m. to 9 p.m. IST. Attendance is mandatory. And we'll basically purge people who are not able to join. There are no excuses here, unfortunately. You can totally game the system, just have it on your mobile and do your own thing, but you will have to be attending the class. For example, right now I see 103 people. That's probably the cutoff for today. So 20 people got purged today based on that. I'm unsure if I'll be this strict today, but most probably I will. And agizake, attendance is mandatory. If you don't come, you'll basically get purged, which basically means you'll lose Discord access. You will not get access to any other live videos, doubt support, anything else. So it is a full-time commitment that way, and keep that in mind. If it's very easy, great. Just do the whole thing, assignments, let it play in the background. If it is very difficult, ask us questions. We only have 100 people. We've handled much more online. So I'm sure I can answer all the questions needed. If there are more questions or more TAs needed, we can add them as well. But this is the only sort of time constraint expectation that we have. Okay, every Tuesday, 7 p.m. to 9 p.m. IST or 10 p.m. IST, you're available on the Zoom call. We have logs of who's joining, who's not joining, and based on that, we'll be purging people. When we say a purge, we mean you're basically let go from Discord and you lose all the perks of Superdevs. All right. Wednesday is when you'll get an assignment. Either Tuesday night or Wednesday, you'll get an assignment. It'll be very close to the test cases that you've solved in the past. Not everything can be tested that way, but a bunch of things can be. But generally, the assignment will have some sort of tests that you have to pass. And there will be criteria here as well. So, assume you have to pass 80 to 90% of the tests. And if you don't, that's a second way to get purged. Not everything is available on the internet. You guys have access to LLMs. So I'm sure it is not very hard to get 80 to 90% if you have a week to solve the assignment. Generally, feel free to discuss with each other. Do not cheat. There will be plagiarism checks. There won't really be AI checks. Honestly, there might be, but make sure the whole thing isn't vibe coded. You understand what you've done. This assignment will be submitted on Sunday. Probably, again, 8 p.m. IST Sunday is the assignment submission deadline. Whoever doesn't submit gets purged. Whoever does submit but doesn't meet a certain criteria gets purged. If everyone does it, no one gets purged. And then Monday we'll be solving the assignment. It'll probably be done by me or someone else. We'll see who takes that class. Most probably it'll be me only. So same time. So Monday, 7 to 9 p.m. IST, we'll be solving the assignment, or I'll be solving the assignment and answering any doubts if need be. That's the high level of the schedule. Does anyone have any questions in this? That's pretty much the only thing to keep in mind. This is expected to be a full-time commitment. We have to select 20 people that will be giving out a stipend to. The stipend will be for $2,500. Honestly, in an online fashion, I'm assuming you guys will start to lose motivation, and it'll be very easy for us to reach the top 20 because people will not attend, people will not be able to do assignments, or they will forget to do the assignment. I think everyone who targets the assignment will be able to do it if you give enough hours. My only worry is, in an online fashion, it's easy to get distracted and do other things, which is great. It makes it easy for us to reach from 100 to a 20, and the 20 is what we'll focus on for placements or connecting to companies, because 20 is a very small number, and we at least have enough opportunities for half of them. So if we can get 50% of them placed, so 10 people placed and 20 people grants, and some of them can do their own startups, that's a great win for us. But assume it's very competitive. 100 people right now, because 20 people got purged immediately. Amongst the 100, we'll see how many are able to finally graduate after 8 weeks. Is that clear? Any other questions on this? Let me scroll down. Monday attendance is mandatory. I will answer that later. I would assume not, but I will tell. I don't think Monday attendance should be mandatory. We will not make tests vague, but even if they are vague, they're expected to be vague for a reason. If they are wrong tests, they're wrong for everyone. So we'll try our best, though. Okay, everything is more streamlined than the original set of tests that we wrote. Anyone has any other questions? Recording will become available probably the same night or the next day. One of these two. Most probably on the. 1 second, let me check if I'm recording. Indeed, I am. Yeah, it'll probably be, it'll come to you max by Wednesday, but most probably 3-4 hours after the class. Our top 20 people are getting referrals and help for jobs. I mean, there's no strict number. Honestly, someone might be really good, and they probably don't need to go through the cohort, and then we can refer them immediately. But the goal of Super Devs, the cohort, is to finish it, and then the top 20 are the ones we're most focused on. That doesn't mean we won't be able to refer more people, or they're removed from everything. I think a lot of people will pass Super Devs, but our goal is to find the top 20 who actually get the stipend. And then we'll see how many we focus on. But stipend is only limited to 20. Any other questions? If you have a general excuse, it's a great question. I have no idea how to answer this question. I think most probably it will not work. I guess it's unfair. So I'll think about it, but you might have a general, I don't know, medical issue and you might not be able to attend. I don't know what to do in that case. But for now, assume you'll still get purged. Do I need to know the basics of us to get started? Yes, I'm just going to talk about that soon. But anyone have any other questions? Last call, then we can kick things off. And be very honest about how much you know, how much you don't know. Yeah, I think one absent in a cohort, in the entire cohort, isn't the worst idea in the world. We'll see. That sounds right to me. But again, let me think about it. Weekly assume it's 100% attendance that's required. That's a little too strict, but we'll see. Any other questions? Cool. Recording will be released at max by tomorrow, most probably tonight. You'll get the link to it. If someone is graduated from top Super doesn't fall in top 20, are they good enough? Yeah, exactly. Referrals pool will be bigger, but again, it'll depend on the number of opportunities. I don't think in a month I can find 20 referral opportunities. As I said, the number would probably be 10. Now, is that restricted to only those top 20? I don't know. It's probably merit-based. If someone hasn't attended classes, hasn't graduated, but is really good, of course, they'll get referred first. It's purely merit-based. It's not like, if you've graduated in the top 20, so you'll be given any preference for someone who's really cracked but wasn't able to graduate. Does that make sense? This mic is very uncomfortable. All right, we'll kick things off. Very honestly answer this. We have, so let me share the slide with everyone. Your side. Let me just make sure you guys can see it. Yep, there we go, everyone. These are the slides for today. And I'll start with a few questions, which I'm hoping you guys answer very honestly. So do not lie about them. Very honestly, let me know. If the prerequisites are these 2 videos, which were posted on the website, and they don't, that's the second one. There are 2 videos of Rust that I have in a Rust playlist. And if I have to take you through the syllabus, it looks something like, just give me 1 second. Rust Bootcamp. Yeah, assume at least all of this. So you understand why do you need Rust, set up Rust on your VS Code locally, understand variables, conditionals, loops, functions, memory management in Rust, borrowing, ownership, the borrow checker, heaps versus stack, things like these, mutability, ownership, borrowing references, structs, enums, pattern matching, error handling, result enum, option enum, iterators, collections, vectors, hash maps, cargo, packages, external dependencies. And amongst these, it's a good idea for you to know, I guess everything else I'll cover. So forget this. This we'll cover today. But anything else, if you don't know over here, just select no. And if you know everything from top until cargo, then select yes. Okay. The first poll is, how much do you already know all of this, which is already covered in 2 videos on YouTube. Probably a little more is covered on YouTube. But do you already know this? Do you already know this? Please give honest answers. If the answer is no, this is not being tracked, you can't track this. So don't worry if you're not getting purged based on this. We just need to know the speed we need to take in the cohort. So do you already know everything from top to cargo, packages, and external dependencies? Yes or no? Okay, so 75% said yes, 25% said no. That is a little surprising because I don't think you should have been able to pass the assignment if you don't know all of this. That means some of you have vibe coded, which is fine. As I said, we are not going to judge based on this. I'll also not go very slow based on this. I do expect you guys to complete this yourself in this week. So in this prerequisites section of the slides that I've already shared, you will find 2 videos. Abhi ek hai. This one is good enough actually. You don't really need the second one, but I'll put 2 videos here. Your goal for the 25% should be that you complete this one and the next one by the end of this week. By the end of this week, you should be able to finish both of these, and then you should be able to understand what we're teaching today as well. Both of these things are expected from you. The assignment for this week, you will only be able to do if you've gone through the prerequisites and also the class that we're covering today. With that, at 7:30 exactly, we're going to start the class for today. Now tell me, how many of us understand this? How many of us understand meta programming, macros, declarative macros, and not just using them, writing them yourself? How many of you understand ASTs or have done some compiler design, have written at least one macro in the past on your own, in Rust? They exist in various languages, but specifically, how do you write code that writes more code in Rust? How do you do meta programming in Rust? What are declarative macros? What are procedural macros? What are the types of all 3 of them? How do you write them? Not just use them. How do you write them from scratch? How many of us already know this? Give me a yes or a no. The amount of monkeys here is insane. All right. Honest answer. Love to see it. I would say pretty much close to expected. 20% understand, 25% understand, and 75% don't. No worries. Slowly, we'll wake our way up. We'll understand what are macros today in Rust. Their docs aren't the best. They're a little incomplete. I was trying to go through them yesterday to see if we can learn from the Rust book directly. Unfortunately, it's a little incomplete. There are other books that you can read just for macros. The reason we're using macros or learning macros is because of 2 reasons. One, if you're writing a smart contract, you're going to use them extensively. Most probably you'll write a smart contract in Anchor or Pinocchio, which aggressively use macros. So you'll have to learn how to use macros, not write them. Unless you want to contribute to Anchor or Pinocchio, which right now with the advancements that keep on happening on Solana, for example, Token 2022, there is need for more macros in both of these repositories. Pinocchio is just starting out, and Anchor has to keep up with Solana development. And hence, that is one path you can take, which is contribute to these libraries. Generally, if you join a Web2 company where you're a systems engineer, you'll write a bunch of these. Or you don't really need to write them. You just need to know how to use them. So we'll kick things off with the simplest thing. We're not just learning about macros. We're also learning about traits today. High level, this is a mind map of what we're going to learn. We're going to learn about what are traits, which is a very simple concept. If you've done very basic object-oriented programming, you will learn this, or you'll already know this. Macros we'll understand, which is a very broad sort of a topic. And there are various types of macros that exist. Generally, you don't need to know their names or their types because you just use them and you know how to use them. But if you really define it by the book, there are 2 high-level types of macros. There are declarative macros, and there are procedural macros. They're different, or you use one over the other when you are, when you're in a very specific, based on आपको कितना difficult चीज बनानी है, how difficult of a thing you want to make. You use procedural macros versus declarative macros based on how difficult of a thing you want to create. What is an example of this? Basically, I guess I should first define macros, but basically if you create something like React in Rust, you will need procedural macros. If you want to, write HTML or JSX in Rust, because you can write frontend in any language, including Rust. If you are writing JSX in Rust, or if you're writing SQL in Rust, then you can try to create it using declarative macros. But most of the times you will use procedural macros for this. They give you more freedom on the input. What is the input? We'll talk about. But that's, you would basically prefer this for very difficult things. You would prefer this for easier things. And even when you're trying to learn them or you're trying to create them, this is a little easy to do. This is a little hard to do. This is also divided into 3 types. Type number 1, a custom Derive macro. Type number 2, attribute like macro. Type number 3, function macro, which is very close to declarative macros. These two are very close in how they look. And the reason I've sort of connected custom Derive macros to a trait is because they sort of work with each other. You use a custom Derive macro to sort of implement a trait. What that means, we'll talk about. So I've thrown a lot of things at you. This is a very difficult thing to throw at someone in orientation class. So don't worry, हम एक-एक को आराम से पढ़ेंगे. We'll understand each one of these one by one. But what are we learning today? High level, traits and macros. Sort of low level, various types of macros, the difference between procedural macros and declarative macros, and 3 types of proc macros that exist. Does that make sense? Let me start off with the very first and the simplest topic for today, which is traits. This should be straightforward, shouldn't take us more than 15 minutes. And I'm assuming some of you already know this. Fire up your compilers locally. Make sure you have a simple Rust project running locally. Let me do that as well. This I'm not spending time on. I mean, you can open Replit and do it over there or on your local machine. Create a new folder called whatever, Superdevs, where you'll do all of these things. I already have it, so let me not remove it. SDevs, and create a folder in there, whatever you want to call it, week 1, or something else, and initialize an empty Rust project in there. Run cargo init to initialize an empty Rust project. I'm assuming this also we know. Okay, create an empty folder called week 1. Inside that empty folder, run cargo init, and that will initialize a fresh Rust project for you. And this is a binary. What is this? This is a binary. Are there other types of projects you can create? Yes, you can run cargo init --lib to create what's called a library. We'll come to what a library is. Right now, we're just creating a binary. What does that mean? That means this is a final thing that you run. A binary, as the name suggests, is a final binary that will get spit out from this code that you will run. What is a library? Library is something that doesn't run independently. The binary sort of depends on the library. That's the difference between. I mean, if you've done the prerequisites, you would know this, but there are 2 types of Rust programs you can initialize, either a binary or a library. If you have done turbo repo at all, if you have gone through code bases of Node.js, there are very similar structuring over there. If I open a random cal.com or let's say dub.sh code base, you will find 2 types of projects in there. This is a very big repository which has multiple individual projects. It has one binary, apps/web, and it has a bunch of libraries. CLI is one library, email is one library, embeds is one library. What does it mean for something to be a library? It means कि independently नहीं चलती है. That's a little debatable because CLI will probably run independently, but emails doesn't make sense independently. UI doesn't make sense independently. The UI module will be used by the apps/web binary. That's an equivalent. Your final Next.js website is a binary, and your UI library or your Prisma schema is a library. App/web is a binary. UI library, Prisma schema is a library. Binary versus library. What are we initializing right now? A simple binary. What does it look like in Rust? If I open this in Cursor or Visual Studio Code, it looks something like this. And if you've done C++, if you've done Golang, then you understand what this is. This is a main function. JavaScript is a little different. It does not have a main function. C++, Rust have a main function, which looks a little different from, other languages. How do you do it in C++ or JavaScript? You write function main, or, you write int main in C++, right? And you return 0 over here. This is the return type of the function. This is what you're returning. This is similar. This is that you're defining a function. This is the name of the function. This is where you give the arguments. This is how you can, give a return type. And this is a console.log equivalent. But is it? What is this? Is this a console.log equivalent? Is this a function call? Or is this a macro? This is indeed a macro. If I hover over this println and click on it, what does it say? It says macro rules, println. It has some weird, I don't know, something over here. So this is not a function call. Even though the first time you write Rust and you open it, you're like, there goes a function call. This isn't a function call. This is a function call. But as soon as you add an exclamation after this, it means it is no longer a function call. It is a macro invocation. It is a macro invocation. What does it mean for it to be a macro invocation? Macros padh rahe hain hum. What are we learning today? Macros. And the first thing we see when we initialize the Rust project, we see a macro. Why is this a macro? This is a macro because it is called like this. But what does it mean to be a macro? It means कि ये कोड कभी रन होता ही नहीं है. This code never runs. Let me take a screenshot of this and put it in Declarative. Put it on the left. When I run the command cargo run, I see hello world over there. What does that mean? Does that mean this function was called? What happens when I open this function? I see something very complicated and weird over here, but it looks sort of like a function. Okay, maybe a function call, and there's another function being called over here called _print. Is that what is happening? When I run this, when I run cargo run over here, when I run cargo run in my terminal, does it mean that control reached here and then control reached, I don't know, here, and then this function got called? The answer is no. When you run cargo run, when you run this command, first a binary gets created. It gets built basically. It's like C++. If you've ever written a C++ project, what is the first thing you do? G++ a.cpp-o/bin, something like this, right? You tell the G++ compiler to take the CPP file and spit out a binary. Is that true or not? That is how you compile a C++ project. This binary is what runs eventually. Same is true for Rust. You can also run cargo build first to create the binary, and then you can actually run the binary from ./target/debug/week1. That is another way to do it. You can run cargo build first to build the binary, and then you can run it. When you run cargo run, same thing is happening. First a binary is being generated, then it is getting run. But when you build it, this compilation step creates a binary, and then that specific binary gets run. And whatever, when this binary runs, hello world gets printed on the screen. There is one more step that happens between, the final binary build and this Rust code. This Rust code getting converted to the binary. In दोनों के बीच में एक step और होता है. That step is macro expansion. Call it, I'm just calling it macro expansion. I don't know what it's actually called. But this code gets converted into a different code. And that code is what actually gets converted to a binary. You have written this code. The developer has written this code. But because there is a macro invocation here, पहले ये code एक और code में convert होता है. This gets converted into a different high-level Rust code. And that high-level Rust code eventually gets converted to a binary. So is this also compilation? Sort of. It's not compilation. It's macro expansion. The macros get expanded. What are we learning today? We are learning about meta programming. What is meta programming? It is programs that can write more programs. It is code that can write more code. What is meta programming? Code that can write more code. And what is this println statement? Println is a simple macro invocation or a macro call that writes more Rust code. It doesn't get called at runtime. I repeat, this doesn't get called at runtime. At compile time, this gets expanded into something like this. And we can actually confirm that by running cargo expand. If you run cargo expand in your terminal, you will see it spits out something closer to what you wrote. It has a function main, but it doesn't have a println statement anymore. What does it have? It has this stdio_print format args hello world. So your higher level code in Rust first got converted into other higher level code in Rust, which is what gets converted into a binary. So if you look at this println macro, यहाँ पे यही तो हो रहा था. If you try to read it, I mean, we'll get to this and what this are and what are these branches, but what this macro is saying is that if println is called with no arguments, then simply print /n, एक नई line डाल दो, add a new line. Or if it is called with some arguments, which, this is where it gets really hard to read and write, कि हाँ ये arg:/tt, what is this? And what is this star over here? And what is this dollar over here? But if there is some argument in there, then, call the _print function, inside which you're, calling another macro over here. You're calling another macro, format args nl, and you're passing in the arguments inside. So this single line of code gets expanded into a lot of lines of code that you can see by running cargo expand. When you run cargo expand, you see this very big code. If I copy this, paste it here, these are the final set of steps that happen if you have a macro in here. If you don't have a macro, then this and this will look the same. There will be no macro. There will be a step of macro expansion. It will do nothing because there is no macro in here. But if there is even one macro or 5 macros or 20 macros, then this gets converted to this. This is what gets converted to a binary. That binary runs. That is the very first sort of explanation of what a macro is. It is similar to this being TypeScript code, which first gets converted into JavaScript code, which is actually what runs. This println is not a function. This never runs at runtime. इसका कोई वजूद ही नहीं है runtime पे. The binary doesn't have a println function. It has these, _print functions in them. It doesn't have this println function. Then what is the goal of this println function? It is to make development easier. It is to make so that the developer doesn't have to write so much code, because this is how you print something on the console in Rust. So do you expect users to write this? No, right? You expect users to have a high-level println macro. Another good question that comes at this point is, why is it not a function? Why is it a macro? Why can't it just be a simple function that takes, multiple arguments? The answer is, we'll come to the answer, but basically, this println function calls can get very complicated. You can, pass in something like, you all guys already know this, but, a variable over here. So if I write let x equal to 1, it can have 2 arguments. It can have 3 arguments. It can have 20 arguments. What you pass in this macro can get very complicated. When things get like that, when you are trying to almost call a function, but the inputs are very vague, they can be anything, is when you create a macro rather than creating a simple function call. When the input gets really vague, आपको नहीं पता क्या होगा, you don't know how many arguments there will be, you don't know the types of the arguments, they could be of any type, is when it makes sense to write a macro rather than writing a function. A macro runs at compile time. So you can do a bunch of checks for you at compile time. And a function, of course, runs finally at runtime. So it will do all your checks at runtime. That's the very first explanation of a very first macro that we have seen, which is a declarative macro called println. And you can sort of start to read it a little bit. थोड़ा समझ आ रहा है कि हाँ, if I don't pass anything, that probably this is what will come in the final Rust code. Let's try that out. I would expect that to happen. If I simply call println and do a cargo expand, what do I see? I see stdio format args /n, which was the very first branch over here. This branch gets called. But if I give it any argument, be it 1 argument or 20 arguments, if you guys have read regex in the past, if you know what regex is and how do you do pattern matching in regex, doesn't this look very similar? In regex, I think you have a question mark, or I think you have a dollar only. And star means that you can have multiple of these arguments. And this is the actual argument inside, and this is, it needs to have a type or whatever this TT is. But can this be read if you understand regex? Can this be read as, acha, there are multiple arguments that can be sent, and we are just forwarding all those multiple arguments to a format args NL, which is another macro that does something with that. So if there are two arguments that I give to it, ASD and a variable A, then these two arguments are what get forwarded over here to this other macro, so on and so forth. So that is a very first explanation of the first macro. We didn't need to go here. We were learning about traits first. But do we understand this? Do we understand a very first macro in Rust, which you probably never need to look at because you will always use println. You will never need to go one level up below and look at what it expands to. But since we're going to write macros today, we need to understand what these are and what they do. Do we understand this? Are we good to go? All right. Simple enough. Okay, slowly going down. Agar yahan pe halat kharab hui hai, then things are going to get bad. So it's a 91%. It's fine. See, I mean, in a live class, when I'm throwing so much at you, it is expected. Okay, some people don't understand. So take your time after the class. You know what to learn it from wherever, but make sure you learn or remember this by the end of it. All right, we're going to move on to the very first topic for today now, which was macros. Which was traits, which is a very simple topic. And you can build intuition for it really quickly. Let's say you have a struct called rect. I repeat, you have a struct called rectangle that looks something like this. I mean, if you want to write it from scratch with me, we can do that as well. So, you have one struct called rectangle. This is the very simplest, example you would take if you're learning object-oriented programming. Okay, there is a shape class, which is extended by a rectangle, whatever, class, and a square class and a circle class, something similar. Let's say you have a rectangle struct. What would a rectangle have? It would have, a width, which can be anything. You can have it to be an integer. You can have it to be a float. Let's say it's an integer. And a height, which again is an integer. And then you have another struct called, square. What will a square have? It will have a side, which will be U32. And you can have a circle, cuboid, whatever, multiple shapes. Now you know for a fact, okay, whenever you use these, whenever you create a rectangle shape, let's say let R equal to rect, width 20, height 10. Again, I'm assuming you can write this code. You understand what are structs, and you understand, how do you declare a new struct. And let S equal to square side 10. One very common thing you would expect, or one very common functionality you would expect on these shapes is to calculate their area, calculate their perimeter. Now, very known object-oriented example. The other example is, a dog and a cat which belong to an animal class, and then they do a bhaw or a meow. But a better example is you define two shapes, and you know for a fact that rectangle ka area bhi nikalna padega. So you will need to have a function called, rect area that will take a rectangle as an input and return a U32, which will simply return, R dot height into R dot width. We know this. And then we will have to define another function called rect square, which will take a square as an input. And, we'll simply do a R dot side into R dot side. And this is great. You can have 20 different types of shapes. You can have a circle, a polygon, a hexagon. And you can define an area function for each and every one of these. But it doesn't look like a class. It would have been nice agar ye ek thoda class ki tarah dikhta, like classes in JavaScript or classes in Java. So how can you do that? Do you remember this? Do we understand how can you implement functions on structs? You can run something like impl rect and define an area function in here. And then you can implement square, and you can define an area function over here. Again, this is all part of prerequisites. So if you don't understand it right now, just go through the prerequisites and you would. Now I have defined a rectangle struct, which has a width and a height, a square struct, which has a side. I have implemented the rectangle struct to have an area function that returns a number. Square area function returns a number. Now notice the function signature looks very similar for both of these. It takes a rectangle as an input, returns a U32. Takes a square as an input, returns a U32. If I add a third thing over here, a circle, same thing. Takes a shape as an input, returns a U32. So even though this works and there is nothing wrong in it, actually looks pretty good. This is how you would write, you would probably structure this a little better. You would have a square.rs file, a rectangle.rs file, so on and so forth. You would not shove everything in the same file. But other than that, a struct, implementing a function on it. If you want to print the area of the square, what would you call? r.area. And then, if you want to do the same thing for the square, you would call s.area. Now, this gives us our very first error, which is, sorry, I did something wrong here. It will not take a rectangle as an input. It will take itself as an input. And I'll talk through this a bit, but again, this is covered in the prerequisites. But I'll probably spend some time here. Because if 10% didn't understand the first thing, this will be a little hard to digest. But basically, this code works. Now, why is there an @self over here? I will talk about, don't worry. But other than that, if you read through it, a rectangle struct, beautiful. A square struct, beautiful. Implement an area function here. Implement an area function here. The only tricky bit is, what is this @self it is taking as an input? And what happens if I don't pass in an @self over here? Does it still compile? It does compile. I mean, of course, if I return something random over here, it does compile. But then what is the need of @self over here? What does it do? And then, same for square. And this is how you define a rectangle. This is how you define a square. This is how you print them. Let me run cargo run. And, hopefully the area gets printed. 200 for the first one, 100 for the second one. That looks right. 20 into 10 is 200. 10 into 10 is 100. Great. अब एक पहला सवाल आता है कि what is this @self over here? And I think it should be self-explanatory, which is that if you call r.area, the specific r that you're calling it on, in this case, we're calling it on this rectangle struct, you get access to that over here. You get a immutable reference of that thing here. You get a immutable, मतलब उसको आप change नहीं कर सकते हो, reference of that thing here. You can read values from it. You can't really update values over here. Mutability is a whole different concept. Prerequisites very well covered. But यहाँ पे, if you write @self over here, you can call r.area. If you don't write @self over here and try to return something random, for example, a good function here might be function_to_string, or I don't know, shape, which returns something like a rectangle. This is a good example of a function that doesn't need to use anything from that instance. Isko farak nahi padta. It doesn't care what r is. It is going to return rectangle in every case. So here you don't really need access to @self. You don't really need it to run on an instance of a rectangle. You can directly call it on the rect struct. So rect : name. What was it called? Shape. This is one way to call a function on a struct. This is another way to call a function on a struct. This is a static call. This is a static call. It is equivalent to if you have written a class called rectangle in JavaScript, where there is a constructor and then there is a function called area. In this area function, you will use this dot width into this dot height. But you will define a static function called name or shape, which will simply return rectangle, something like this. So this is an equivalent in the JavaScript world. You will define a class called rectangle. And the area function is bound to this, which means the specific instance. But shape can be a static function. So how would you call shape? You will simply call it rect.shape, like this, console.log. You can directly call it on the class. But if you want to call area, you first have to initialize a rectangle with whatever shapes inputs you will pass into the constructor, width, height. And then you will call r.area. So this is how you call a non-static function. This is how you call a static function in JavaScript. The same is true in Rust. You can define both types of functions in Rust. You can define a static function which doesn't take @self as an input, which means it will directly get called on the class or the struct. In this case, you will call rect : shape. That's how you call a static method that is not attached to any instance of a struct. That's how you define a struct. That's how you call r.area on a specific struct. Simple enough. I'm hoping simple enough. I'll do a poll soon enough. But एक बार traits खत्म कर लेते हैं. Now everything is great over here. I have two structs, two implementations of the same-ish function. At least the function signature looks very similar. So one very common thing that happens in, again, the Java world or the JavaScript world is you first create a class called shape. And then you write another class called rect, which extends shape, right? And, a class called circle, which extends shape. And then a class called square, which extends shape. What does extending it mean? It basically means whatever functionality exists over here needs to exist over here as well. That is not what a trait is. There is another thing in Java and JavaScript called interfaces, where you describe the shape of a shape, the structure of a shape. Yeah, this needs to have a function called area that needs to return a number, something like this. You just define the signature. कि हम चाहते हैं, we want whoever implements this shape needs to have an area function. So if all three of these implement shape, then all three of these need to have, function where, they will do the respective business logic. This will return width into height, that will return pi into r square, this will return side into side. So an interface in Java, not even JavaScript, but an interface in Java is very close to a trait in Rust. A trait, नाम ही बता रहा है. Trait मतलब क्या होता है? What does a trait mean? It means some people have good traits, people have bad traits. And both of these are going to have shape-related traits. Both of these are shapes. So what you can do is, you can define a trait called shape, where, you want anyone who implements the trait shape to have an area function that looks like this. So a trait in Rust is very close to an interface in Java or an interface in JavaScript, where you define some traits, some properties, some characteristics of whoever wants to implement this shape. So if rectangle wants to implement the shape trait, you will write something like impl shape for rectangle. And inside you will write the implementation. If I don't give it an area function, it will start to complain. It will say, yaar, ye shape trait has this function. Please define this function. So you will have to define this function over here. Return self.width into self.height. And same is true for square. Impl shape for square. इसका फायदा क्या है? What is the benefit of doing this? Why did I write impl shape for rect? Why can't I simply write impl rect? The benefit is okay, now you can define a function called get area, let's say, that can take a shape as an input. I repeat, is this right or is this right? Impl shape. I think this is right. That simply returns s.area. Something like this. You can define a function called getArea, which can take any shape as an input. Could be a rectangle, could be a square, could be something else. As long as whatever is being passed implements the shape trait, area will be called on it. And, that could be an area of a rectangle, square, or whatever. So it just makes it easy to define such generic functions. Now, getArea is not the best function. Like I guess a better function is getArea and perimeter together. Something like this, which returns a tuple with u32. And यहाँ पे we get back s.area, comma s.perimeter. And we add the perimeter to the trait, as well as as soon as I add the perimeter of a shape to the trait, these start to complain. We need to provide the respective implementations here as well. That will not be true if I do this, but that will be true if I implement shape for rectangle. And I will have to provide the respective implementations, which in case of a rectangle is what? Self.width plus self.height into 2. And the same thing will be true here. It will basically be self.side into 4. That's the perimeter of a rectangle, right? 1, 2, 3, 4. What is the perimeter? The sum of all the sides. So for a rectangle, it will be width plus height plus width plus height, or width plus height into 2. For a square, it will be side into 4. And now this function, sort of makes sense. इसने एक shape को input लिया. It took a shape as an input and returned the area and the perimeter of it together, which might be a use case that you have. Rather than calling r.area here, I can simply call print. I don't think I can directly call this, but let's say something like this. I mean, basically this. Let perimeter area perimeter equal to get area and perimeter of I can pass S in here as well. I can pass R in here as well, because both of them implement shapes. Both of them implement shapes. Baki ke, if I add a third shape over here that doesn't implement shape, तो उसको मैं pass नहीं कर सकता. I can't pass 1 over here. It will start to complain because 1 doesn't implement shape. What does it say? It says the trait bound integer shape is not satisfied. What is this called? It's called a trait bound, and it is telling you 1 नहीं implement करता trait को. 1 does not implement the shape trait, but perimeter does. Sorry, square does and rectangle does. This is me actually implementing it for rectangle. This is me actually implementing it for shape. If I remove this, then I can't even pass in S, because it will say the trait bound is not satisfied. I need to make the trait bound satisfied by actually adding the implementation block. Do we understand traits? Let's do a poll. If you want, I can push this code and let me do that in a bit, but let's just see how many of us understand traits. This was actually an easier concept and also a prerequisite, so I'm assuming this wasn't too difficult, but give honest answers. If the answer is no, then we know. We'll see what to do. We'll decrease the pace a bit, but do we understand traits? Beautiful. Why are we learning traits today? Kyunki slowly let's make our way to macros. Let's define a new struct, remove everything, called user. What would you expect a user to have, guys? A name, string, an age, number. That's good enough. Let me define a user, name, and age reveal, no. And let me try to print the user. And notice something weird is happening. I can print numbers. Let x equal to 1. Println doesn't complain. I can print strings. Println doesn't complain. But if I try to print a struct, it starts to complain. Why is that? Why is this user not getting printed? Why do I see a red squiggly over here when this is just a simple struct? It's not complicated. It's a simple struct. If I hover over it, user doesn't implement the display trait. What does it say? कि कहीं तो कोई display trait exist करता है. Somewhere there exists a trait that looks like this. Display. Standard FMT display. There is somewhere a trait that exists. And that trait I haven't implemented on user. So what will I have to do? Impl debug, or sorry, what was the trait called? Was it debug or was it display? Display. So what will I say? I will say, I'm going to implement this trait for user. Then I will try to read through this trait. Ki, achha, ye hai kya? Okay. There is a trait called display. It has a bunch of, again, macros, but ignore them. A bunch of comments on what is this, how to use them. But here is a good example. Implement display for position. What does it say? It says that if you define your own struct like this, then you will have to implement display on that struct. And this is what it would look like. It will take self as an input, and it will take a formatter as an input, and it will return a result. And you can call this write macro inside and return whatever you want. So we can do this. This is a great example over here. I will copy the example. I'll be like, I'll paste it. ये जो display trait है, this display trait, if I hover down, expects this one function to be implemented. if I want to implement display for user, I will have to implement that function for user, which makes sense. You have defined your own struct. The compiler doesn't know how to write it. The compiler doesn't know how to print it. You can't just give, create a random struct and expect the compiler to know how to print it. That is a debatable statement. Because JavaScript में ये होता है. If I define, let x equal to, whatever, user equal to name 𝗟𝗶្ឍage 21, I can print it. It will not complain. But Rust says, if you define your own struct, tell me how to display it. You have to tell me how to display it. And for that, it expects you to, implement this display trait. Traits हमने अभी इससे पहले किए थे. Shape trait we did. Similarly, there is a display trait that you have to implement for user, where I can do something like this: self.name, age, and name is this thing, age is this thing. I'm hoping you guys understand what's happening here. We're just importing from the standard library, from the format library, the display trait, and from the standard library, from the format library, the result enum. Sorry, is this an enum? Result type, and this write macro. तो अब हो गया. देखो, the error goes away. Beautiful. There is a display trait written somewhere, and if you try to print, you can only print if you have implemented that display trait for the user. If you haven't implemented that display trait, वो नहीं चलेगा. How does it get implemented? It expects you to take a formatter as an input and write to that formatter however you want the thing to be printed, which in our case is name is user.name, age is self.age or user.age. If I run this now, it does compile, it prints name is 𝗟𝗶្ឍ, age is 18. This is one way to implement a trait. But there are many traits that exist which are very hard to implement. Some of them you can't only implement. Some of them, even this is like too much boilerplate code over here. There should be a default implementation. I repeat, there should be a default implementation. ये इतना मैं लिखता थोड़ी रहूंगा. This is where declarative macros come into the picture. This is where, sorry, not declarative. This is where derive macros come into the picture. Abhi tak we saw one macro, which was a declarative macro, println. When we started to see its implementation, we saw something like this: macro rules, println, 2 branches. If no inputs are given, this gets spit out. If some inputs are given, this gets spit out. ये हमने कर लिया है. We understand declarative macros a little bit, at least what they look like. This is not a macro yet, but wouldn't it be nice if a macro can spit this out for me? Wouldn't it be nice? अगर ये कोड भी कोई लिख दे मेरे लिए, wouldn't it be nice if someone can write this code for me? Why? Because there should be a default implementation for this. This is a simple struct, like there is a name and an age. Just print the thing as an object. And this is where the very first procedural macro comes into the picture, which is वो चलेगा नहीं यहाँ पे because there is no display macro, unfortunately. So this is how I would have hoped कि यार somewhere there exists a display macro जो इस कोड को मेरे लिए लिख देगा. I would have hoped कि somewhere there exists a display macro, a derive macro that would write this code for me. It would, of course, not write it in such a clean fashion, but it would, just print both the fields that exist. Whatever the first field, which is name, and the second field that is age. I would have hoped that somehow I can add one line of code in here, and this just gets spit out for me. That would have been really nice. But display in Rust means the display trait in Rust, the display macro doesn't exist. But if it would have existed, it means user ko kaisa dikhega. What would it look like to the user? When you do println bracket open bracket close u, this format function is what gets called, right? इसके अंदर जो लिखा है, that is what will get printed. When you do an implement display for user, whatever is written over here is what gets printed over here. When you are displaying something, it means you are displaying it to the end user. You don't want a default implementation for that. If ये थोड़ा complicated है, but like compiler people are compiler people, you know, their brain works a certain way. उन्होंने क्या कहा? What they said is that we will create another type of way to print. This is one way to print. If you want to display a variable, this is another way to print. If you want to debug a variable, they said, if the developer is debugging something, this is how they should print it. If a developer is showing something on the front end or sending something back to the front end, this is how they should send it. This goes into the display trait and calls the FMT function. This goes into the debug trait and calls the FMT function. The debug trait looks very similar. Ekdam same cheez hai. Exactly the same, you know, implementation. Implement debug for position. Inputs are also the same. Output is also the same. But whatever is inside this gets printed when you call this. Notice there is no error right now, because I've implemented debug, not display. Display we were doing before. Now we were implementing debug. Now if I remove this, there will be a red squiggly, because I'm no longer implementing display. Now I'm implementing both display and debug, and hence this also works. This also works. To recap, there are two ways to print a variable in Rust. One is you print it like this. For that, this thing, whatever you're passing, should have implemented the display trait, should have implemented the display trait. I have done that over here. Implement display trait for user. Or the second way is this. When you do this, whatever is passed in here should have implemented the debug trait. Now there are people said, debugging is for developers. इसकी default implementation दे दो. Let's give a default implementation for this. So they wrote a macro. I repeat, they wrote a macro called the debug macro. Abhi I had written debug over here. This was the debug trait. What am I putting over here? This is the debug macro. Pub macro debug. This is the debug macro. This was the debug trait. When you write derive macros, derive procedural macros, custom derive macros, they always exist in a pair. एक trait होता है जिसको वो implement करते हैं. There is a trait and they implement that trait. Whenever you write hashtag derive debug or anything else, you know, clone, copy, there are many such derive macros that exist. Whenever you write such a macro, you're actually implementing a trait on it. It is an easy way to implement a trait. So what is the second type of macro you're learning about? This is the first macro, which is a declarative macro. It looks something like this. It has, you can create multiple branches in here. Based on the input that is passed in, one of these branches runs and you run some code in there. Charger, 1 second. I'll do Q&A very soon, like before we proceed. If this is getting a little heavy, I'll also do a poll, don't worry. My charger isn't running. Charger. I'll take a small break. How are we doing? I'll open chat. Are people doing good? I just want to make sure my laptop is charging. But do you understand everything? Yeah, thoda upar se ja raha hai. Are you guys able to understand everything, or is it going from? Why format args is not expanding using cargo expand? That should be a macro, but that is probably an internal macro. That's a great question. Yeah, Google that and let me know. My guess is because it is an internal macro, that's why. Thank you. All right. I Google didn't implement it. Okay. Please release the recorded video ASAP. Sounds good. Sounds good. Good. All right. So This is the first type of macro, and the second type of macro we're understanding is a custom derive macro. जिसका काम इतना होता है, the goal of a custom derive macro is given a trait, it derives that trait for you by default. Now you can override that as well. If I want, I can re-implement debug for user, but it gives me a very nice default implementation. Why is display not a trait? Why did they not create a display trait? Because Rust people were like, display is for end users. Don't give it a default implementation. It will look very ugly. An end user shouldn't see it. An end user as in someone who's using your application. Debug is fine. Let developers debug. We'll give them a default implementation. What does the default implementation looks like? It looks something like this. User name Harkirat, age 18. So it was able to print a very nice looking struct for me without me having to implement a trait. You can implement a trait and do it. But isn't this very easy? Look at the amount of code I had to write. And you can always run cargo expand and see what is actually happening. When you run cargo expand, implement debug for user, someone wrote, the macro ka owner wrote that code to finally add these lines of code. Function fmt, formatter, return a result, and what does it print? To the formatter it prints user, name, self.name, age, self.age. So ये code उसने खुद लिख दिया. It was able to write this code for me. I did not have to write it. A while back, I wrote it myself. You guys saw it, right? I wrote these two code blocks, impl debug for user. But if I add the debug trait, if I add the debug macro, it automatically implements the debug trait for me. And this is the first type of sort of macro that we'll deal with, or more technically, the first type of procedural macro that we'll deal with. It is only meant to be used when you have a trait and you want to give a default implementation to that trait. That is the case in which you use a derive macro. You might have seen things like this as well. Function get user, and get slash user slash slash API slash user slash user ID. If you've done Actix Web, which I'm assuming some of you have because you all passed 10 plus test cases, you might have seen such macros as well. This is a different type of a macro. This is an attribute-like macro. This is a custom derive macro. We are learning this right now, a custom derive macro. When does this guy make sense? This guy only makes sense when you are trying to derive a trait. आप एक trait लिखोगे, आप उसकी default implementation लिखोगे. You will write a trait, you will write a default implementation for it. Going back to our original discussion, what traits we understood very good. Macros. Fundamentally, macros are a way of writing code that writes other code. Whoever has written the debug macro has written some code that writes all of this code. Whoever has written the println macro has written the code that writes this code. So, what are macros? Code that writes more code. This is also known as meta programming. It is a general concept, not just specific to Rust. You've used println, that's a macro. Vec is a macro. All of these macros expand to produce more code than you've written manually. आपने जो manually code लिखा है, this is the code that you wrote. You can expand the code and actually see what actually it gets converted to by the end of it. Macros versus function. This is an interesting discussion. It comes from the Rust book. Let's read through it once, digest it, and then we will, I'll answer a few questions and we'll do poll and then we'll proceed. Fundamentally, this is very good. Rust book is very good. It has less details about all types of macros. This section is really nice. Fundamentally, macros are a way of writing code that writes other code, which is known as meta programming. Let's read this line. If you've used println and vec macros throughout the Rust book, if you've gone through the Rust book, all of these macros expand to produce more code than you've written manually. You write manually one line, it gets expanded to 5 lines. Meta programming is useful for reducing the amount of code you have to write and maintain, which is also one of the roles of functions. Functions do the same thing. Why do you use traits over functions? Because functions also are used to abstract some code out, put it in a different file. Then also your final file will look very clean. However, macros have some additional powers that functions don't have. A function signature must declare the number and type of parameters the function has. A function signature, if there is a function called println, it needs to, describe the type over here, input, which will be a string. It is not like JavaScript. You can't do this, dot inputs. You can't expect variable or variadic, whatever you call it, amount of arguments. Only you have to clearly describe input kya hai. You have to clearly describe what is the input and its type. It's concrete Rust type. Is it a U32? Is it a struct? Is it a enum? Is it something else? Macro mein, you can pass as many arguments as you want. And if you remember a while back, I said you can actually pass HTML in here. In a macro, you can literally pass this. If you're writing React code, then something like a component. Return, if this was a Rust component, it would look something like this. Function, I don't know, to-do underscore or create underscore to-do. Let's say we're writing some front-end code. So, it would look something like this. It would return using a macro, React underscore component, a div inside which you have an input, inside which you have whatever, a button that says create to do, so on and so forth. You can get this creative with a macro. A macro can parse any input as long as you can parse the abstract syntax tree of this. If you have learned about languages or compiler design in the past, you might understand what are tokens or what are ASTs. If you can parse these, इसका अगर आप code लिख सकते हो, okay, of course you will write this actual macro where you will have to write the code to parse the HTML and whatever. If there is state management in here, then replace user underscore name, so on and so forth. But you can do such atarangi things with macros. You can't do that with functions. Function mein you can't pass HTML as input. You can only expect a number, a struct, a enum, a string, so on and so forth. But with a macro, you can literally shove C++ code in here or HTML code in here. And as long as whoever has written the final, macro can understand it, compile it, and return back something back, can deserialize it, send it to a front end, you have created a React or more technically Next.js bolunga main se. This is Next.js because you're doing server-side rendering, or EJS, if you've heard of EJS, in Rust. Because Rust allows you to, or macros allow you to pass anything in there. Function would expect, something specific. That is why writing macros is hard, because you need to define this language up front and then understand how to parse this language and then, understand what the user wants to do. So it's almost like you're writing a compiler. If you write procedural macros, I repeat, if you write procedural macros, it's almost like writing a compiler for HTML, or if you write C++ here for C++, or if you write SQL here for SQL, so on and so forth. So that's why you would want to use macros over functions in some specific use cases. The downside to implementing a macro instead of a function is that macro definitions are more complex than function definitions, because you're writing Rust code that writes more Rust code due to this indirection. Macros generally are more difficult to read, understand, and maintain than simple function definitions. Another important difference between macros and function is that you must define your macros and bring them in scope. But basically, you can define a function below and use it over here, but you can't do that for macros. Macros should be defined above and used later on. You can't write a macro below and use it upper, which should be obvious if you understand how languages are actually run. When a language runs, it first creates a map of all the functions. So even if a function is defined at the end, it will be available, versus macro expansion happens during compilation, where first the macro needs to come, then the invocation needs to come. All right. So that is what a macro is. And it is of 4 types. We've discussed this before. A declarative macro, println, simpler macro, only covers some use cases, will not cover extremely complex use cases like HTML that I wrote. Procedural macros can cover complex use cases like HTML or other things. Is of 3 types. Custom derive macro. And do we now understand why this is closely related to traits? A trait is something you write, and then you can implement that trait using a custom derive macro. As a developer, you can write the debug trait, and you can write the debug macro as well, so that other people can derive a default implementation for that trait. That is why these two are closely related. And then comes procedural macros, which are of 2 types: attribute like and function like. This and this are very similar. They look very similar. It's like you're calling a function. That is why it's called a function like procedural macro. An attribute like procedural macro, I already showed you. The get function that I wrote a while back. That would be a attribute like procedural macro. So if I press command, let me just write all 4 of them once in, a single line. This is what, this is a declarative macro. Struct user, derive, debug. This is what debug is a derive or custom derive procedural macro. Name, string, age, 32. And let's say this runs some TCP server. So there is a function get underscore create underscore user, inside which you're going to write some SQL code that actually puts something in the database. So SQLX : exec, query, insert into users, values, whatever, you read it from the input somewhere from the arguments, and then lastly route, get /user/ or a post endpoint, I would say. So hopefully you can read this. This is a attribute like macro, and this is a function like procedural. A function like procedural macro, an attribute like procedural macro, a custom derived procedural macro, and a declarative macro. Now, question is, what is the difference between this and this? Both of them are function like. Why can't they be the same? And the answer is how they are eventually expanded. Declarative macros are a little easy to expand and are a little, it gives you certain things you can pass in. You can pass in, strings or expressions or types. Versus here, you can pass in anything as long as you can compile the final thing. Sorry, not compile. You can understand and parse out the tokens, create the abstract syntax tree, figure out what your language is or whatever you expect to pass in. You can parse that over here and generate more code. Versus println or declarative macros are for simpler things where you just have 2, 3, or 5 different branches that the user can pass. They can pass in a string, or they can pass in nothing, or they can pass in 2 strings, or they can pass in an expression, so on and so forth. If the user is passing in simpler things, then you would use a declarative macro. It's easier to write also compared to a procedural macro. If you want to attach an attribute like this to a function or a struct, or if you want to derive something on a struct or an enum, a trait on a struct or an enum, or if you want to write a function like macro, but this thing inside is very complicated, you need to parse it out to an AST yourself, is when you would use procedural macros. So what are the 4 types of macros? One is declarative macros. Simple, gives you a bunch of branches. Based on the branch, specific codes gets replaced. Procedural macros, which is of 3 types: custom derive, attribute, and function. Function wala is similar to declarative macros. Only thing is the developer gets more power on the input that is passed over here. Attribute macros, if you don't want to derive a trait, if you simply want to do something else, add some functionality to a function, to a struct, to an enum, then you would use attribute like macros. Notice I don't write derive over here because I'm not deriving something. This is not a custom derive macro, which is the 3rd type. This is used when you have a trait and you implement you provide a default implementation on that trait. Do we understand various categories of this thing? Let me do a poll. If cargo expand doesn't run for you, I think you have to do a cargo add, cargo expand. You have to add that as a dependency, only then it will work for you. I'm going to do a poll and then we'll do, some chat for a bit. Then we'll move on to creating our very first macro, which is going to be a little hard, but we're going to try. Launch the poll. Do we understand 4 types of macros? At least using them, their usage. How do you use a procedural macro, a declarative macro? Okay, 96% is great. That's beautiful. So then let's do 2-minute, chit chat, and then we'll move on to that. Iske baad all the slides are just, sharing various types of macros. So, what is a declarative macro? For example, here I ask you to create a very simple eval declarative macro that takes some expression as an input, 2 + 3 × 5, and evaluates it. So whatever done over here, there will be an expression that will come. Just return that expression as such. So kya hoga? This will just come over here, let answer equal to 2 plus 3 into 5, that will be 15. That's what gets printed. And this, I've created a new vector macro, but vec is already a macro, right? You guys already know you can create a macro like this or a vector like this. Let v equal to vec 1, 2, 3. That will initialize a new vector, but this is also a macro. And they have some more complicated implementation over here. I have done some, a slightly basic implementation, which will be hard to read again. Okay, what is happening over here? Okay, there are multiple expressions that can be passed. That's probably what a dollar and a star means. Okay, matlab, there'll be multiple comma separated variables, which will be an expression. So that will be 1, 2, 3 like that. And we need to create a temporary vector. We need to, for every, what does dollar bracket open bracket close star mean? Okay, for every x that exists, we want to push it to the vector and then we just return the vector. So if you look at this vector macro, simple declarative macro, right? Like declarative macro is very simple. A single branch exists right now. You can add another one for an empty vector. Let's say, there's an empty vector and I return an empty vector. But this is generic enough. Even if you don't pass anything, this branch will hit because star means 0 or more. I think star means 0 or more. I could be wrong. If it doesn't mean 0 or more, then we'll have to change this. But let's copy this. Like this is, if you look at this code, it's already in the slides. You can do it on your side as well. If you look at this vector declarative macro that I have created, what do I say? Here, there will be multiple inputs that will be passed. There will be what is dollar open. There's an expression, comma star mean. It means there are multiple inputs, multiple expressions, multiple variables that you get access to in X. X is multiple inputs, 1, 2, 3, 1, 1, 2, 3, 4, 5, based on however many inputs came. This is the code we want, this macro to be replaced with. Let temp vector equal to new vector, do this and then return. So if I do a cargo expand here, I will see let answer equal to all of this code, which is, it generates a new vector, pushes 3 things, returns the vector. So answer mein kya store ho jata hai? What does answer have now? It has a vector of these inputs. Notice I can call it like this and like this. I have not put any sort of a constraint. Okay. Macros you can invocate. Anyway, you can invocate them like this also. So it doesn't matter, if this feels confusing, this is a function call. You can invoke it however you want. This is a vector. It takes multiple expressions as an input. And what are we doing with those expressions? We're just pushing them one by one to a temporary vector and returning the vector from here. That is the simplest declarative macro. Rarely do you write these. Most of the times you will write procedural macros. Any framework that you look at, Anchor, I have not seen Pinocchio, but I've seen Anchor. Most of the times you're writing procedural macros. You are not writing declarative macros. You're not writing this thing over here. Declarative macros, very simple. Rarely do you write them. If you do want to write them, there are branches, you pick the specific branch and go in. It gets a little more complicated, of course, if you actually want to write them. But what are we going to focus on? Procedural macros, where you can shove in anything. 3 types, custom derive macros, very simple, already seen it. Derive, BOSH, serialize, BOSH, deserialize. You've probably seen this in the Solana world if you've written any contract. So this is also a custom derive macro. It probably, there is some serialize trait that exists in BOSH. It implements that. Debug macro, we just saw. You understand this very well. Copy and clone are also good. Read through them. Through the docs, nothing crazy here. Attribute like macros. Here is a good example of them. This is an attribute like macro. Notice I am actually implementing it on the field of the struct. Okay, I want name to be replaced with full name when I'm putting it in a table. Let's say, there is another macro over here that is SQL or Postgres that is implemented that will automatically generate SQL queries for you. So, rename equal to full name, matlab, whenever this gets, in this case, it means whenever you convert this to JSON using 𝗟𝗶, rename this name to full name. Skip serialization if means, okay, if email is not present, don't put it in the final JSON. And skip means, okay, don't put password in the final JSON when you're serializing. So, these are good examples of attribute-like macros. And if you've done 𝗟𝗶 at all, or done database using 𝗟𝗶 or ORMs, then you've probably seen these because you have to rename them a lot between how they go into the database and how they look in your Rust code. And lastly, function-like macros, which again, SQLX queries, the simplest example here. This is how you use them, and where you will use them, where would you see them. The question is, how do you create one of your own, which is the goal for today's video. The goal is not to use a procedural macro or a declarative macro. It is to create one of our own. So that is what comes in the next section. Now, do you want to take a breather or shall we get right in? Let me open chat. If you want to take a breather, we can take a 5-minute breather. If not, we can get right into it. So let me open chat and see how everyone's doing. How are we doing? Breather. Good. 5 minutes, 10 minutes. We'll take a 5-minute break. Brain is not braining. Abhi to shuru mein nahi hua, guys. It hasn't even started. When it starts, things get crazy. Is hashtag, what a beautiful question. Is hashtag derive debug implement all structs? Geeta Pranay. Let me copy the question only. It's a good question. The question says, is derive debug implements all structs? If there is a struct called user which has name age u32, does hashtag derive debug implement this? Or is it able to implement this? Let's see. Let u equal to user name string from Edith and age 32. This is the code that I've written. If I call cargo expand, notice it is able to expand the trait for me and print something. Now, let me add a third thing here. I don't know, last name string. Okay, let me do cargo expand again. And now it has user name, age, last name also. So what is happening over here? If I change the struct, its expansion changes as well. Notice what did I say? कि ये जो होते हैं इतने simple नहीं होते ये हल्के में मत लेना. This is like inside this you get access to the whole thing, and you try to literally parse out the Rust language. Figure out, अच्छा, there is a field called name, there is a field called age, there is a field called last name, and you spit out your final code. When this debug trait gets invoked, even though you can't see its code because it's written in the compiler, what does it say? Compiler built in. इसका code मैं पढ़ नहीं पा रहा हूं. I can't read its code, but inside it gets access to all of this. It can figure out the name of the struct. It can figure out all the fields that exist, and hence when I expand, you get the name of the struct and all the fields that exist. So yes, debug can implement any struct that you write. In fact, if this struct depends on another struct, like address, there's another struct called address, which has city, which is a string, and pin code, which is a number, let's say. As long as debug is implemented on both of them, I can define an address, which is city and pin code. What? It can expand this as well. So it doesn't matter how nested it is, doesn't matter how hard it is, because it has access to the whole thing. It can, create a much more complicated this for you, macro for you, or it can expand whatever you want or whatever you put over here. Good question. This is a good question. Does Anchor do security checks using procedural macros?
Hello, everyone. Welcome.
I saw the same thing before the class. I saw the other one, declarative macros. Does Anchor do security checks? Okie dokie. Quite WhatsApp. I'm going to close it. That was PG wali auntie. I think food something question. But what was I saying? Also saw this before the class. I didn't see these. I saw the other one, but good. I thought he didn't have one. But anyways, does macro affect CEO optimization? So macros run during compile time. Anything that affects CEO optimizations or generally compute units, it's just what the macro got expanded to. If it got expanded to something very complicated or very intense when it comes to compute, of course, you will spend more compute units trying to run that code. So that's what Pinocchio solves, right? It's not like it has different types of macros. They at least look the same functionally, but whatever is implemented inside, it makes it more and more, optimal. Security checks, I don't think they do security checks using proc macros, at least the ones that I've seen, the standard macros that exist in Anchor. I'm unsure if there are any security checks that happen over there. Can we nest procedural macros? That is a great question. I think we can. We just saw that, right? But yes, I think we can. Serial attacks, again, I don't know if Anchor specifically will check for them during macro expansion. I don't think so, but I could be wrong. Correct me if I'm wrong. How often do we create macros ourselves? You mostly use them unless, as I said, only when you are writing a framework like Anchor, or at least on Solana. If you're writing a framework like Anchor, Bosch, Pinocchio, that's the only 𝗟𝗶 from time to time. If you're writing these frameworks, then you would, otherwise you wouldn't. Which again, it's like probably 0.01% of the developers. Very hard to find developers that actually write them. It's good to know though, generally for computer science. If you want to understand compiler design and ASTs, it's good to know. But again, the assignment will be heavily on it. Just because it's not used as often doesn't mean we don't have to do it. Cool. A little bit of difference between procedural and declarative macros. It's just how a developer writes them, or what the developer gets access to when they're creating procedural versus declarative macros. When you're creating a declarative macro, which println is one, notice what it looks like. It looks something like this. There are multiple branches in which you can, if the input looked a certain way, then run this branch. If an input looked a different way, then run this branch. That is different from procedural macros, where you literally get access to whatever is written inside. For the debug macro, for example, you literally get access to this full struct, and then you're supposed to parse it out yourself and convert it into a representation that you understand and go from there. So that is the difference between procedural and declarative macros. You would want to use declarative macros because they're easy to read and write, but a lot of times they are not enough, which is why you have to use procedural macros. But you would want to use declarative macros because for a simple use case, they just work. There are like 3 branches you need to read. And the input is very parsable. It's, a bunch of strings, maybe more than one strings, something like that. But if the input itself is a struct, then, that is where, you get access to the raw struct that you need to convert to some format where you can read the name of the struct and the name of field number 1, the name of field number 2, the type of field number 1, the type of field number 2, so that you can expand it into something else. For example, this debug thing, if you saw, it expanded it into something like this. It got access to user, which is written over here. It got access to name, which is written over here, and that is what it printed over here, so on and so forth. So when you need access to everything inside and parse it out in something very complex, is when you use procedural macros, otherwise declarative macros. Beautiful. Shall we write one? Shall we write our own custom derive macro? Part 1, simple stuff. No macro over here. Very simple thing. Derive macros are created to derive traits on struct. So we're getting back into the class, guys. 8:45. Good break. This slide, try to understand. Next slide, even if you don't understand, it is fine. After the class, go through it. Try to do it again 5 times. This slide, though, you should be able to do. Doesn't really cover any macros. Simple Rust code that we have written until now. All right. Creating our own custom derive macro. So there are 4 types of macros. There are 4 types of macros. Custom derive macros, attribute like macros, function like macros, and declarative macros. This is the one that we are writing today. Assignments will be on one of these 3. It will only be on procedural macros. It will not be on declarative macros. Assignments will only be on either custom derive macros or probably attribute like macros. Most probably it will be on this. So the assignment is going to be on this. But what are we creating? This. We are creating a custom derive macro today in class together, hand-holdy fashion. And then the next assignment is going to be on you guys writing your own attribute like macros. Make sense? Let's kick things off with the first part. No macros, simple stuff. Derive macros are created to derive a trait on a struct. समझ आता है? अभी समझा था थोड़ी देर पहले. Debug is a derive macro, a custom derive macro. Let's create a trait called serialize and deserialize. We will create our own trait called serialize and deserialize that supports two functions. The serialize trait takes a struct as an input and returns the struct in a vector of bytes format. And a deserialized trait, where I've added this small constraint, okay, whatever you're deserializing needs to be of a fixed size, which basically means it needs to have only numbers in there, not strings. Right now, we're only discussing structs which have numbers in them. That is it, fixed size numbers. No strings, no arrays, no vectors, or arrays can be there, but let's say just no vectors right now. Simple numbers. We want to create traits, serialize and deserialize. And we want to create default implementations for them. We want to create a custom derive macro for these two traits. So we need to create two custom derive macros for these traits. Both should be able to pack a struct into bytes and vice versa. If you have done Solana until now, you have seen the Bosch serialize and the Bosch deserialize structs. If you have done Solana until now, you have seen the Bosch serialize and the Bosch deserialize macros, which is, this one right here. We're trying to create something similar. Okay, given a struct, I repeat, given a struct that looks like this, swap. If you're swapping two tokens, you probably will give the quantity that you're expecting, quantity underscore one, what you're giving, let's say 100, which will be a number, and quantity number two, which is, what you're expecting back, which will again be a number, or, more technically an 𝗟𝗶𝗀, because it will be a positive number, something like this. Given such a struct, we want to create a derive macro, serialize, deserialize, that would implement the serialize and deserialize traits that we have written. What did the serialize and deserialize traits look like? They look something like this. They need to pack the struct, I repeat, they need to pack the struct into a bunch of bytes and vice versa. So if your struct looks like this, let s equal to swap quantity underscore 1 is 10, quantity underscore 2 is 20, something like this. If your struct looks like this, if I call dot serialize on it, if I call s dot serialize, it should get converted into one number has how many bytes? Let's make this simple, 1 and 2, let's say. One 𝗟𝗶𝗀 or 𝗟𝗶𝗀 has how many bytes? 4 bytes. 1, 2, 3, 4. 32 bits is how many bytes? 4 bytes, right? So what should this get converted into? Something like this: 0, 0, 0, 1. That's quantity 1, and 0, 0, 0, 2. That's quantity 2. That's very close to how Bosch serializes numbers as well. If you use Bosch serialize, I repeat, if you use Bosch serialize with two numbers only, it serializes it very similarly. It just does it in the opposite direction. It would do something like this: 1, 0, 0, 0, 2, 0, 0, 0. That's how Bosch does it. How do we want to do it? Okay, when you are trying to serialize a swap struct that looks like this, this is what it should look like. And vice versa, if you ever have a bunch of bytes, if you look at the deserialize function, it is a static function. It doesn't have @self. It takes an array of bytes as an input. So it will take something like this as an input. And when you call deserialize on it, so you'll call swap deserialize, and you pass this as an input, this array of bytes as an input, or this vector of bytes as an input, this should get spit out. This is exactly how Bosch serializes and deserializes more complicated structs for you, which have pub keys, which have a bunch of things, PDAs, quantities, numbers, strings. In our case, we're sticking to something simple. We have a fixed size struct By fixed size, I don't mean you can't have multiple quantities. You could have a quantity 3. You still need to support it. The number of fields can change, but they'll be fixed size. They'll not be a string. They'll be a number. And for now, they'll only be a U32 and I32. You can assume that our struct needs to be a U32 or an I32. Doesn't have to be anything complicated. We need to implement these two. We already have written the traits. We need to implement these macros. We need to write these macros that are going to get access to this full struct, and they need to be expanded to something else. Just like this guy over here has a bunch of things, and this debug macro gets expanded to something like this. Is the problem statement clear? How you do it is a different question. Is the problem statement clear? What needs to be done? Let's do a poll. Do we understand what do we need to build? Just like there's a debug macro, we need to create a serialize and a deserialize macro, which takes the full struct as an input. Now we need to figure out how to pass the struct, how to find 3 different fields in there, how to convert them, into this byte format, write the code for it. And that code is what it should get expanded to. And vice versa. When we write the deserialize macro, we need to somehow implement this deserialize trait on swap. And given a bunch of bytes as an input, convert it back into this swap struct. Do we understand the problem statement? Okay, problem statement नहीं समझ आई बहुत लोगों को. Okay, 88%. Okay, that's fine. This slide is very simple. It's not even that. It's much simpler. The part 1 is actually pretty easy. It doesn't use macros at all. So let's do the part 1 first. Let's add these 2 traits to our code base. I have a code base where I have a serialized trait. It's very similar to trait shape, right? That had function area, took at self as an input, and returned a U32. That was the shape trait that we wrote a while back. This is a serialized trait that we're writing right now, where we want a function serialized to be defined, which will take that specific struct as an input and return a vector of arrays and a deserialized trait, which if you want, feel free to ignore this one. So let's just make this much. Convert us. This is a trait, and we're going to write structs now. Struct swap, which has quantity 1, which is, let's say, U32, quantity 2, which is U32. And we want to implement serialize for swap. Chalo bhai, itna kar lete hain. Given a struct which has fixed fields, doesn't have multiple fields, we cannot add quantity 3 over here in the future. No, only has 2 fixed fields. You want to implement the serialize struct or trait for it. So you have to implement this. How would you do this? Let's solve this first. Leave macros aside for a second. This to you guys can do. यहाँ पे थोड़ा byte conversion ही तो है. Take the first one, convert it to a bunch of bytes, add that to a vector. Take this one, convert it to bytes, and add that to a vector, return the vector. So you would define a vector over here. Let v equal to vec empty. Return v from here. Beach ka logic likhna bas. So somehow you need to do a self dot quantity 1 dot 2 bytes, something like that, and add that to vector. Aisa kuch karna, right? We have to do something like this. Try to do the whole thing. This is not generic. This will not work if I add quantity 3 over here. But at least it does what it's supposed to do. It implements the serialize for this specific struct. It doesn't implement serialize for all the structs that might exist, quantity 3, quantity 4. But iske liye it will implement it. It will implement it for this much. So can you guys try to finish this? Take 10 minutes. Take the starter code. It will remain on the screen. I'll just answer questions until then. Can you try to finish this code right here that's given on the screen? Again, we need to do it in the right format. So 0001, 0002, like that, just like bytes generally show. If anyone has any questions, chat is open. Otherwise, please try to finish this, this function right here. And if you're able to do this, then finish the deserialize also without any macro. Is a good idea to create macro which can deserialize the raw data coming from Solana Geyser plugin into a struct. So what is Solana raw data? It's just a bunch of bytes, right? And it looks in a certain format. Do you really need a macro for that? Probably not. I think every transaction that is coming to you from Solana is going to have, a bunch of instructions, a bunch of signatures. You know the format really well. It's not vague. Now, inside the actual bytes, the actual transaction bytes or the instruction that you're sending, I don't know if you need a macro for that. You don't need a macro for that. Yeah, I don't think you need to create a macro for that. That doesn't sound like a good idea. So accounts, transactions, exactly. So I think the reason this idea came to you is because, and correct me if I'm wrong, Anchor has a bunch of, you have to finish this, like basically this much to do. Now read and understand what needs to be done. And maybe I'll write out, he realizes quantity underscore 1 and 2 into a bunch of bytes. So, this. That is what you need to solve. I think if you split your spaces in GPT, it'll give you the answer, but try to write it yourself. This is where you'll be writing the code. All right. Someone has written it, extend from slice to the byte. That's perfect. Extend, yeah, yeah, that is right. Fahad Khan. Why B bytes? Why not LE bytes? Because that's what I've mentioned here, right? So this is little endian and big endian, I think. It basically means do you want to do it like this, 1 0 0 0, or do you want to do it like this, 0 0 0 1? In our case, I mentioned you have to do it like this. Borch does it the other way. It does little endian, so 1 0 0 0 is what it does. But we want to do it this way. Any other questions? If there are, please ask. Nito, finish this up. 5 more minutes, then we proceed. 2 people are on site here as well. I don't know if they're trying to solve it. Yeah, LE takes least significant bit, B takes most significant bit. Yeah, Daksh, what you have written also looks right. There is an easier way to write it that Fahad above has written, or even Jay Kumar has written, but yours is also fine. You write reading over all the bytes one by one. These videos will be posted in superdevs like superfun.dev, whatever, superdev.com. Claude's in the month. All right, we'll kick things off. You weren't expected to, implement any macros over here. It was pretty simple. A few of you have written this. I think, I could just get this solution right here. This one's the simplest one. So if you look at it, the way they've done it is, we have defined an empty vector and v.extend from slice basically extends the current. It's similar to append. It appends or concats, whatever the better end of this. It basically appends all the bytes that are over here, and self.quantity1.2b bytes means if the number is 1, you'll get an array like this 0 0 0 1. And there is another function over here to LE bytes that would convert this to 1 0 0 0. So it depends on you. Do you want this type of a serialization format or this type of a serialization format. What we're trying to create is a serialization library. Given a struct, convert it into a bunch of bytes. Given a bunch of bytes, convert it back into a struct. So given this, this was sort of the expectation for serialize. And what would deserialize look like? Again, we'll define a trait called deserialize, which will, take a function, which will have a function called deserialize, which will be a static function. It will take, a vec of bytes as an input, and it will return a swap struct, something like this. So that is what the deserialized trait would look like. How do we implement the deserialized trait now? So impl deserialize for swap, and we'll have this function there, which will take a vector of bytes as an input, and it's supposed to return the swap struct. So how would you do this? Again, over to you guys. What do you have to do? Take the first 4 bytes, that is quantity 1. Take the next 4 bytes, that is quantity 2. Then simply return swap of, quantity underscore 1, quantity underscore 2. So, what would quantity underscore 1 be? V of 0 to 3, something like this. What would quantity underscore 2 be? V of something like this. This is just a vector of bytes. How do you convert that into a number? And then that is what gets stored in quantity 1. Similarly, quantity 2, do this. You should probably have some checks, if whatever v dot length is less than 8, then that's a problem. Ideally, it should be equal to 8. But if it's more than 8, you can ignore. But if it's less than 8, then there's a problem over here. So you should throw an error over here. Should you throw an error or should you do something else? You should probably, return a result from here, and not just a swap, because the inputs can be incorrect. And if the inputs are incorrect, then we return the error variant. But if everything is correct, then we return the OK variant. So hopefully this is like readable and not going too fast. But if I am, let me know. This is the only thing that needs fixing. Everything else is, covers all the cases. If the length is less than 8, then, we should throw an error, but you don't really throw an error in Rust. What do? You return a result enum with the error variant, which is what I've done over here. But if everything is fine, then you return this. Question is, how do you take a bunch of bytes and convert them into a number, a 32-bit number? How do you take a bunch of bytes here and convert it into a 32-bit number? Can you figure that out? Take 5 minutes. Can you finish this deserialize function? We'll go from there. Any questions? Yeah, you already solved it. You don't want to, that's fine. Yeah, people have a few different ways to do it. Serialize, this is deserialize. Yeah, that's fine. Only one user to revise. That's fine. This is the easiest one, which I like. So let me copy it. The whole thing. It is the whole thing. Let me paste it now. Again, this will only work if the length is greater than 7. Else this will, basically panic. So ideally, you should convert this into a result, and you should ensure, all the entries actually exist. So if data.length is less than 8, then you should return an error. Else you should return an OK variant. Everything else is fine. So if you read through it, what has he done? Or what have they done? There is this function called from BE bytes that takes an array of bytes as an input, where he's put the first 4 bytes and the next 4 bytes, and gives you back the string. So this is probably a more foolproof solution, because you're checking if you have 8 bytes or not. Everything else looks fine. Can we write a main function now? We have written a trait called serialize. We have written a trait called deserialize. We've written a swap struct. We have implemented swap, deserialize for swap. And you took an array of U8, which is also fine. I took a vector of U8, which is also fine. Let me also take what you've taken. And the return type in the trait and the final thing should be the same. Ideally, the return type should be a result. Because you don't know if the input that the user is sending is correct or not. They can send the wrong thing as well. Swap, implement deserialize, implement serialize. Given you've written all of this, what's left? A simple main function, right? Given you've written a trait number 1, trait number 2, implemented that, written the struct, implemented the first trait, implemented the second trait, you just have to write the final struct. So let s equal to swap quantity 1, 1, quantity 2, 2, and s dot serialize would convert it into a vector. You can print the vector if you want, and then you can convert it back to s2 by using swap deserialize v. And then I'll also implement I'll derive debug over here. What that will do is I can print the swap struct. We've already done this. This return the result, so I'll just unwrap it. Hopefully you guys understand what an unwrap is, and this probably takes an array or a reference as an input. This is a test for it. What does the test do? It defines a swap. It serializes the swap struct into a vector. It prints the vector. It converts the vector back to the swap struct, prints the struct. If I run cargo run over here, I get back 1 0 0 0 0 0 2. What was quantity 1? 1 and 2. Did I miss something? I think serialized function is incorrect. Yeah, this needs to be BE as well. If I try it one more time, 0 0 0 1 0 0 0 2, and if I convert it back, quantity 1 1, quantity back 2. So do we understand the non-macro implementation? I'll push this. This is a lot of code. And I'll just put it in the slides. I guess it already exists in the slides, but I'll re-add it during the class. Oh, it's already over here, so you can just look at it from the slides. A serialized function that creates a new vector and extends it one by one with the quantities. A deserialized function, which I've done it a little differently here. I'll add the solution that I've added as well if you're more comfortable with that one. Especially the deserialized implementation is a little simpler over here. Okay, U32 from B bytes, first 4 bytes, next 4 bytes. So let me go to here and add another toggle here called class solution. Now tell me honestly, first question, 2 questions I'll ask. First question, did we understand this writing a trait and implementing a trait? This trait is not a macro yet. I have not yet reached a stage where I can write, serialize, deserialize. I have not yet reached this state. I have not written my own procedural macros. I have not written my own procedural macros. I have manually implemented the trait. And this trait only works if the struct looks like this. If I change the struct a bit, then the serialization and deserialization breaks. Because I've only written it for 2, so I'll have to write it for the third one as well. So this isn't a generic solution. Like someone asked in chat a while back, does the debug trait work with all structs? It does. Does our implementation work for all structs? It doesn't. We need to write a more generic macro over here. We need to write a custom derive macro called, whatever, serialize, deserialize. That actually writes this function only, but of course does the whole thing. That's quantity 1, quantity 2, and quantity 3. If there are 3 over here, if there are 5 over here, it has 5 over here. It should serialize and deserialize correctly. The problem statement has been made very simple. Bosh serializes everything, including strings and public keys and bytes and numbers and floats. We have restricted ourselves only to U32s. Given a struct that only has U32s, how can you write a serialize macro that converts it into a bunch of bytes, a deserialize macro that converts it back into the struct? That is the last thing we have to do. First, I will ask, did we understand this simpler implementation goal? Did we understand the simpler implementation without a macro, simply converting a struct to a bunch of bytes, a struct that we already know about? Not a new struct, not a complex struct, not an unknown struct. This we understand, 95%. Now tell me this. इसका अगला part अभी करना है या घोड़े खुल गए हैं? Do we want to do the next part right now? Or do we want a video tomorrow or an offline video, or do you want to do this yourself? Whatever. Basically, can you digest what's coming next, which is, this very big AST creation? If you go to the next slide, it has everything. I've tried to add as much hints as possible. But the next thing we have to do, which will take another 40 minutes to an hour at the very least, is creating our own custom Derive macro. So that by the end of it, we simply have to write this. This is what our code will look like by the end of it. Okay. A swap struct where this and this are simply derived. These two derive macros are just derived. We don't have to write the implementation ourselves. Now I'll give 3 options here. Polls. How to proceed? Let's do this right now. 𝗟𝗶𝗀𝘀, cover this in offline video. And third option, make this part of the assignment. Remember, you guys are competing amongst yourselves, top 20 slots or whatever. So, I don't know if you guys want, ये assignment uska part ho chahiye, you want to learn it yourself. So whatever. I'm giving 3 options. You want me to do this right now? We'll do this right now for the next 1 hour. You want to make an offline video? I'll make an offline video on it. You want to make this a part of an assignment. So this week ki assignment hai, I can make this a part of that as well, even though the solution is right here, but I'll of course change it a little bit. So these are the 3 options for today, how to proceed. Let's see what you guys answer. And then we will go from there. What would you like to do today, tomorrow, offline video, assignment? Beautiful. Could you guys be more indecisive? 31, 35, 34. 30, 36, 34. 29, 36, 35. I don't know what to do. 30, 35, 35. Okay, I'll end poll now. These are the final results. 37% said I cover this in an offline video. 29% said I do it right now. 34% said make it an assignment. I don't know if majority wins here. I do think most of you will not be able to understand anything I say after this. Because 1, the topic is difficult. 2, you're already trained a little bit. It's 9:14. Where do we start? 7:30. Yeah, I think 2 hours is enough. I'm learning machine learning right now. And after 1 hour, my brain sort of stops in the classes that I do. So I'm happy to stop. I'll decide 2 and 3. May say, what do I choose? I will most probably choose 2. And I'll cover this in an offline video. I think I need to teach this once. And then the assignment will be a little difficult. So I will cover this in an offline video, but that doesn't mean you have the slide, you should do it yourself as well. I still cover it. The code isn't too much. It's just this file. This implement the macro file that exists in the slides. If you really read through that, I'll go through it really quickly. Okay, let's go through it. There are a bunch of steps here. Unfortunately, if you have to define macros, you have to define them in a different crate. That is why the steps are here. You first have to create a new cargo workspace, which is like a monorepo in Rust. Then you have to initialize 1 repo for the traits where you describe your traits, and another another library for the macros, where you set proc macro to true, which means this specific library is going to export a bunch of macros. Then you will add 2 dependencies to this macro crate or this macro library, syn and quote. Syn is used for parsing the input, especially if you're getting Rust input, which we are like our thing, the input that we're getting is going to be a struct. Syn lets you parse that very easily. And quote lets you return the final expanded code that you're writing. Jo code aap likhne wale ho, the code that you want to get expanded to, code lets you write that in, inside a macro so that it doesn't get executed. You want to write Rust code, but you don't want it to be executed. So whatever you write inside quote, is sort of ignored by the compiler, and that code doesn't really run. That code is considered to be the string that you're actually appending and finally creating in your macro. We've defined a trait in a separate library, and then we define the macros like this. This is how a macro is defined. A proc macro derive basically means this is a derive macro. This is the name of the macro, serialized number struct, or you can call it whatever you want. And this is the second one, proc macro define deserialized number struct. Notice it takes a token stream as an input. It returns a token stream as an output. Token stream, which basically means a bunch of tokens. So what is any language? What is C++ code? A bunch of tokens. Those tokens can be passed into an abstract syntax tree if it is valid syntax. If you've written valid C++ code, then all the code, int, main, bracket open, bracket close, all the arguments are called tokens, like very similar to LLM tokens, right? If you write hello there in ChatGPT, hey is probably one token, low is probably the second token, there is probably the third token. Similarly here, if you write any language code, it's actually a bunch of tokens, which if the syntax is right, get converted into an AST, an abstract syntax tree. So, that input you get over here, and you can convert that into an AST, an abstract syntax tree, by calling syn : parse. So this syn library lets you parse Rust code, returns you back the AST. Given this AST is when you have to, finally return the full, because you have the abstract syntax tree. You can literally see ki kya dikh raha hai. There is a struct which has name 1 field, quantity 2 field, quantity 3 field. First field is a number, second field is a number, third field is a number. You get access to all of that in this AST. Given you have access to this, you need to start writing all the code that needs to be returned from this macro. So if you look at the macro finally, you get the AST and you specifically tell ki iski type ye hogi. You force the type, or you not force the type, you tell the compiler, because it is a derive macro, right? This is what we're creating by the end of it. It is a custom derive macro. So sort of for a fact, this will only get applied to either a struct or an enum. Like derive macros get applied to a struct or an enum, not to a function. So you can assume the type to be derive input, because it will obviously be applied to either a integer or a struct or a enum. Once you have the AST.ident gives you the name of the struct. You'll see this many times, but ident gives you the name of the specific thing. The first thing, the top level thing that we're creating is this struct. So iska jo naam hai, swap, this name you get access to in this variable. So you have the name of the struct. You have a starting point to create the final expansion of the macro. You have the name of the struct. Then what do? You try to read the data of the AST. Kiske andar kya data hai? Is it a struct? Then we do this. If it is not a struct, we panic. We say, we don't support enums. Custom derive macros can be applied to enums. We don't support them. We only support if you have created a struct. This whole parsing of whether is it a struct, what is the name of the struct, is thankfully handled by this library. This library can understand Rust code and create an AST on top of it and give you very simple responses. This is the name of the struct. This is the type that this macro added, which was a struct. This is the data inside the struct. This struct has a bunch of fields. Fields can be of many types. You can define a struct like this: struct swap quantity 1 U32, or you can define it like this: struct swap to U32 U32. This is a named struct, or it has named fields. Quantity 1 is this, quantity 2 is this. This is a unit struct, or it doesn't have named fields. The first field doesn't have a name, second field doesn't have a name. We only support named structs that look like this. So what is the first thing we check over here? The fields of the struct, are they named? And if they are named, we continue. If not, we panic. So our macro will only work if there is a struct with named fields. If there is a struct with named fields, you get access to its fields. You iterate over all the fields. Fields.named.iter.map. What will this do? It will iterate over all the fields that exist. Quantity 1, quantity 2, quantity 3, doesn't matter however many. You will iterate over all of them. you will get the name of that specific field, quantity_1, quantity_2 in this variable, and you will return this quote. What was the other library we used? There were two libraries we added, sin and quote. Sin and quote. So what will you do? You will return this code inside a quote macro. अगर ये code ऐसे लिख दूंगा, if I write this code like this, it will get executed in Rust, right? Which is why you sort of wrap this inside a code. Okay, this is the final output we want to give to the user. Result dot extend from slice. ये देखा देखा लग रहा है. What did we write here a while back? When we were serializing, what did we write? V dot extend from slice. This code is sort of being created over here. Slowly, all the fields are getting, converted into result dot extend from slide. Self dot field name dot 2be bytes. Self dot quantity1 dot 2be bytes. Self dot quantity2 dot 2be bytes. So this code that I had written manually, I was able to get access to the input struct. I was able to get its name. I was able to get the fields. I was able to pattern match on ASC.data, ensure it is a struct, go over all the fields. And if the field is named, only then I would iterate over all the fields and add this result.extend from slice to this field serialization variable. Return this. This is again a little complicated. There's a call out that shares what this means. But basically append all of these together and return that over here. This serialize underscore fields now has all of this code. This Sara code not executed just in a string or a quote you get access to here, and then it basically looks like this. The serialized fields variable will start to look something like this: quantity1, quantity2, quantity. If the struct has 3 quantities, it will have 3. If it has 5, it will have 5. And then finally, what do you have to return? Let generated equal to, again, a quote. We don't want this to be run. We don't want this to be returned. We don't want this code to actually run. This is Rust code. We don't want it to run. We want it to be returned and replaced finally, or added below the struct. Impl serialize for hashtag name. ये तो करना था. Impl serialize for swap. Function serialize that looks like this. Function serialize that looks like this. Define a mutable variable called result. Define a mutable variable called this. Return result at the end. Return result at the end. The part in the middle is what we got when we iterated over all the fields. The part in the middle is what we got when we, this for loop ran and, it iterated over 5 fields or 3 fields or 1 field, and we put that over here. By the end of it, generate.into basically, returns this in the specific format that you need, this token stream format. And that is it. This much will, take a struct as an input that looks something like this, or something like, whatever, 3, 4, doesn't matter however many fields it has. You have created a generic macro that works for all structs that have U32s in them. It gets, it converts them into a bytes, adds them to a result. And similarly, there is the deserialize wala, which is a little harder below it. But works on a similar concept. You get the AST, you ensure it is a struct, you ensure it has named fields, and you go from there. All right, hard to digest. Slide is still here. एक बारी में इसको समझ आ गया वैसे. How many of us already understand this? Let's do a poll. Do you already understand what I have written? Launch कैसे करूं? Stop sharing and relaunch poll. Do you understand already what I've written? Yes or no? एक बारी में समझ आ गया या no? Did you understand in the first go? Okay, 50-50, not bad. Cool. For everyone else, I'll add an offline video. And I'll add the assignments by tomorrow. Even though there's a smaller assignment here that you can try. How does it work if you have multiple types, not just U32, but U size also, I8 also? And how does it work if you have strings also, like Bosch serialize? If you've done that, then you've exactly done what Bosch serialize does. All right. Do you have any questions? Anyone have any questions? What is your problem in Anchor for getting seeds? Because writing seeds manually every time we CPI write. Why don't we write a procedural macro which injects seeds into context like bump does? Bump is auto-generated. Seeds are manually provided. You can't guess them. What do you think about writing a procedural macro and anchor for getting seeds? What do you mean getting seeds? Seeds are developer defined. Developer will define seed 1, seed 2, seed 3. Bump isn't developer defined. It just gets automatically generated. That's why you have access to it in context. But does that make sense? It was easy to understand, looked complex. That is true. Just give them via checking constraints, right? Yeah, we give the seeds manually. I think what he's saying is कि वो automatically कैसे हो जाएंगे. But हाँ ठीक है. I think it's very late. All people are here. Attendance is full, which is great. You guys can call it now. For people who want to leave, feel free to leave. For people who are left, I'm happy to answer questions. But officially class is done. Assignment will reach you by tomorrow. Sunday is the submission deadline, and I would assume पहली बारी में most people would get purged, and then it becomes easy after that. So if you like the class, you feel like you want to do this, it'll mostly be similar difficulty level आगे जाके. So, keep that in mind. And if it's too much right now, you can always join the next one. If you like it, that's beautiful. And there are, of course, no commitments other than the fact that the top 20 are going to get a stipend. And we'll try our best for, jobs. Cool. We'll call it here unless people have questions. So input is basically a byte token stream, and we are iterating over that using SYN and converting it into a struct using no, so input is a token stream. That is correct. I don't think it's bytes. I think it's like actual tokens. So, struct is one token, swap is the second token, opening brace is the third token, quantity one is the fourth token, so on and so forth. You get these inputs. And iterating over them. So what SYN does is it parses it into a Rust object. It just parses it into a Rust object that looks like this. So if you look at, let me. I probably have it somewhere here. I was writing this before the class. Open recent, this one right here. So if you look at, the format it gets converted to is this Derive input format. So what SYN does is it takes an input and converts it into this Derive input format, which gives you the name. नाम क्या है उस चीज का जो बनी है, which is a struct, which is like swap, and it gives you the data and the type. So, AST.data, what is AST.data? It tells you, is it a struct, is it an enum, is it a union? Because if you're creating a custom derive macro, it can only be applied to these three. So it'll either be a struct or an enum or a union. If it is a struct, is when, it gives you access to its fields. So if you look at the fields, a struct can have a named field, an unnamed field, or a unit field, which means, it doesn't have anything. It has unnamed fields. It has a named field. हमारे case में we only focus on named fields. But if, we wanted to in the future support, unit structs like this, or, unnamed structs like this, then we would have the respective, handlers over here, or the respective catches over here for the other types of, over here. The field named is what we support right now, and we panic if not. But, we can add more unnamed unit structs. If we want to support everything, we can support everything. We don't support everything right now, which is why it looks like this. Let me, in fact, show you a very nice thing I was seeing before. So if you look at this, it just works, right? It is a unit struct, it works. Sorry, it's a named struct, it works. As soon as I convert it into an unnamed struct, notice it gives an error. And what error does it give? No. The error it gives is, hold on, I think I have, basically it should give this error right here. Only named fields are supported. If I hover over this, it says only named fields are supported. So literally when you're writing the code, the macro is trying to expand. When you're writing this code, macro is trying to expand. It is trying to expand this. This struct swap reaches over here, in this token stream variable. So token stream has this. Then you try to convert it into an AST. You get the name, which is going to be swap. Then you find it a struct. It is a struct. You reach over here. So, data underscore struct contains this struct in a specific format. But these fields, they are not named. The fields are unnamed. It looks like this. And hence, the control reaches this panic, which says only named fields are supported. And that is exactly the error that you see over here. So if you're writing macros, you should write good messages on the other side, so that whoever is a developer who doesn't have time to look at your macro will just be like, kya error hua hai? Achha, named fields are supported. So I will just convert this into a struct with named fields. quantity underscore 1, youth32. Something like this. Up error hai, whatever. I think now I only support I32, which is why, you know, it was giving the second error, but this is it. Or koi sawal? How it happening in real time? The macro is trying, the compiler, your, what do you call it, LSP or VS Code is, you know, trying to expand the macro and, you know, doing it. You don't, compiling, converting into a binary happens later, but, you know, it is trying to expand the macro in real time. Give us the assignment where we can revise all this later so that we can revise all this. Either way, the submission will be on Sunday. So, you know, doesn't really make sense. Recording should come by tonight or tomorrow at superdevs.fun. Either, or I'll announce the Zoom recording, you know, soon enough on directly on Discord. It's to make macro scalable. Anyone building? What's the question? Iska answer ye hai. It's to make macro scalable. Recap everything we studied. That's a good point. A good recap of everything that we've studied covers these 8 slides or 9 slides. We learned what are we learning today? Traits and macros. Traits, very simple thing. Did a bunch of examples. Learned them. Macros gave a high-level example of what is metaprogramming, and, you know, a simple example of, you know, macros never really execute. They get expanded, and then at compile time, this is what gets compiled. This never gets compiled. Then we understood the various types of macros. So this is a good thing to keep in your head / you know, good mental map of what macros look like. A macro is of 2 types. Procedural or declarative, simpler ones, slightly complicated ones. These are of 3 types: attribute, custom, derive, and function. These are the 4 types of macros. Custom derive macros are closely related to traits, and that's the one that we're trying to create today. Then we looked at a bunch of examples of all of these. Every slide from here to here is just a bunch of examples of attribute-like macros, custom derive macros, declarative macros, and function-like macros. Ye charon bas examples hain. Then we started our actual assignment goal for today, which was to, given a struct, serialize it into bytes and vice versa. But write it as traits, write it as a combination of traits and functions over here. You know, define the trait over here and then manually implement the function. But then we said, what if we want it to happen for any generic struct with multiple fields? That is where this comes into the picture. And, you know, you get access to whatever. The AST, and it works for any struct that you have, irrespective of how many fields it has. And then comes the assignment of, you know, what if you have multiple? What if you have different sizes? Or what if you want to support strings? How does Bosch serialize actually work? Which, you know, supports strings and public keys and use size, and I32 and I8. How do you do that is, you know, the next set of assignments. These are not the final assignments. These are just, you know, good things to do after this. So you'll have to change your code a little bit from the last slide to support these as well. And then you can go one step later. All right. Hopefully that was insightful. I will call it here, and we will see you guys Tuesday. And how is the LSP? I mean, that's how the Rust compiler is working. And, you know, it's not a compilation step that it needs to, how does the compiler give you errors? Like, you know, how does it know semicolon nahi chal raha hai? Because it is constantly trying to parse your code, you know, figuring out if there's something wrong or not. Same is true for macros. Okay, you know, it is constantly trying to expand your macros and go from there. All right. Cool. We'll do a feedback thing after this. I'll send a form. Let us know if you need anything to be changed, rating, things like these. Even if personally he hai, you know, zyada tez to nahi ho raha, slow to nahi ho raha, let me know. I'll post a feedback form on Discord after this. And video recording should come by end of day. And assignment by tomorrow. Have a good night, and I'll see you guys next week. Bye bye.